What's up, students? I am Liana May Giannis and welcome to our physics session. I encourage you to watch it until the end and I'm sure that you will learn on this video. Vibration and waves, they are related to each other. When vibration causes a disturbance in the medium, then it becomes the source of wave. Understanding vibration and waves is crucial to comprehending our physical environment. Vibrations and waves are responsible for most of what we see and hear. Tremble, quake, and oscillate. These expressions describe the movement of a wide range of items. They can even describe how matter moves at atomic level. Atoms wriggle as well, going back and forth. Now, let's shake it up. We will have a quick and simple activity with a little bit of extra music. Grab a plain drum and stick and try to beat it once like this. Did you hear the sounds? Now, beat it again. This time, touch it when you are beating. What did you feel? Next, place a piece of paper on the drum head. Sprinkle a few grains of mango seeds on top of it. Beat the drum head. What did you observe? We can see, striking the head of the drum changes its shape and compresses the air inside the shell. The compressed air passes on the bottom head and changes its shape. Then these changes are transmitted to the drum shell and reflected back, and this action is repeated, creating a vibration. Another example on how objects create a vibration is the bubble head that we often see as a display in houses, office, and even in vehicles. A bobblehead doll is made up of a large reproduction of a person's head that is joined to a body and stand by a spring. The big head bubbles head when lightly tapped wiggles, vibrates, and oscillates the head. The head moves back and forth when pushed or otherwise disturbed. The back and forth isn't going to last forever. The vibration gradually fades away, and the bobblehead eventually stops bobbing and returns to its normal resting position. Do you ever think what causes objects to vibrate? How this is happen? For example, a pendulum. Like this, what do you think is the reason why it didn't stop and how it is related in vibration? All we can do is to find out. From its normal stationary posture, a vibrating object moves back and forth. When an object goes from one extreme position to the other and back again, it completes a vibrational cycle. The frequency of a vibrating object is the number of cycles it completes in 1 second. A pendulum, for example, is a body that is suspended from a fixed position and swings back and forth under the action of gravity. Periodic motion is different quantity that can be used to quantitatively define an object's motion. The frequency is the number of complete cycles that occur in the given time period. Because the second is the usual metric unit of time, frequency measured in cycles per second, the unit hertz is similar to the unit cycle per second. Heinrich Rudolf Hertz, a 19th century physicist who advanced our understanding of the electromagnetic theory of light waves, is commemorated with the unit hertz. Hooke's law will be the topic for our first discussion. It is defined as law of elasticity discovered by the English scientist Robert Hooke in 1660, which states that for relatively small deformation of an object, the displacement or size of the deformation is directly proportional to the deforming force or load. The force thus exerted by the spring on a hanging mass would stretch if you held the bottom of the string and pulled downward. The spring would stretch a little if you pulled it with just a little force. The spring would stretch for far greater extent if you pulled with a much stronger power. Mathematically, Hooke's law states that applied force equals a constant times the displacement or change in length, or we can use the formula F is equal to K times X. The value of K depends not only on the kind of elastic material under consideration but also on its dimension and shape. Let's do another activity. I want you to get a metal glass, a metal spoon, and water. I want you to see how greater vibration is created when there is a greater force applied. First, pour the glass with some water. Now get the spoon and strike the glass slightly, and you will see in the water a few waves that explains that there is light vibration happen. And that concludes our lesson for today about vibration. On this lesson, we tackled the pendulum, a bubble head as an example of vibration, the Hooke's law, and the formula that we can use. Before you proceed to another lesson, you are encouraged to answer the quiz as an evaluation to this lesson. Thank you and good luck!